Good morning, everyone. I'm Carl Daamen, Principal Hydrologist at eWater. Thanks for joining us for the webcast today. We're going to be talking about modelling water demands in source. If you have any questions during the webcast, please feel free to type them into the questions section of the GoToWebinar panel on the right of your screen. And I'll also be taking questions at the end. In fact, I probably prefer to answer most questions at the end. So if you do have anything during the talk, please maybe keep it brief, just a clarification. Okay, so I thought I'd just start, before we get on to the topic of the day, a little bit about what's happening at eWater. We have some training course coming up in November in Sydney, creating water system planning models. And everyone who can make it is welcome to that. We already have enough registered participants to run the course, so it's definitely going ahead, and we're happy to have more people join. We have new production versions of Source for those who haven't seen it. Read the release notes, download and use it. They're a great improvement on earlier versions and some new features there that I'm sure you'll be interested in. And just another note as well, I just thought people might like to know that we've been hosting a group of river basin modelers from Maharashtra and India in the last 6 to 8 weeks, and mainly training and model building. And we're looking to do more of that in future, which is good because it provides us with a different perspective on use of the source model, and it's quite an interesting application. All right, so on with the topic of the day. I'm going to be talking about water demands in source. It's an introductory talk. I'll be covering the minimum flow requirement node, the water user node in particular, and the irrigator demand model within the water user node, the environmental demand node, and I'll talk briefly at the end about implementation of water restrictions in source. So some of the details presented today will be covered in more depth during the training course in November. And I'm intending today's presentation to be an introductory presentation, so proficient source users may not get a lot out of it. But let's push ahead with the minimum flow requirement node first. Minimum flow requirement node generates non-consumptive water orders in your river network. It basically specifies a required minimum flow rate through the node itself. And minimum flow requirements are often used in models, and they represent required water releases from a storage or downstream flow requirements. And they may include simple in-stream environmental flow requirements, but these are covered in more detail by the environmental demand node itself. So the feature editor for a minimum flow requirement node looks like this, and I'll just open one of those within a source model so we can look at it in a bit more detail. On the right here, I have a very simple source model. I'll just open the editor for a minimum flow requirement node, and I'll go through the 5 different options for entering flow rates. We can just type in a value here. So 26 megalitres a day required every day to pass through the node. That would be one way of specifying our requirements. Another would be to load a time series from a data source file, the CSV file, for instance. Here's a time series of monthly requirements over a 10-year period, or a 20-year period, sorry. You could also define required flow on a daily basis if you wish to. Using a function is another option. You can, if we look here at function 1, I've written a very simple function that has a monthly flow rate of 11 megalitres a day. You you have to enter your units over on the right. 11 megalitres a day for January to June, and 22 megalitres a day from July to December. And we can check that our function's working properly just by doing a little, using the parser, doing a little check. So if I enter month 1, that's January, I can see I get 11 megalitres a day. If I enter 8 for August, then we get 22 megalitres a day. The next option is a monthly pattern, and again you just enter the numbers you require directly on the screen here, typing in. And finally we have a rule curve option, which basically allows for multiple monthly flow rates and allows you to define through the trigger function as to which of these flow rates is used, or an interpolated rate between the listed rates. Okay, so there's a lot of, I provided a lot of detail on this, the minimum flow requirement node, to provide a bit of context to the rest of the presentation. I want to move on now to the water user node. The water user node, as it's provided in the source GUI, in the node palette, is shown on the left. But as soon as you edit that node and choose a particular demand model, you get one of these 5 nodes on the right. So let me just look a little bit more at what these nodes do. The first 2 are a time series demand specification and a monthly demand specification. And those were ones that we just discussed in the context of the minimum flow requirement. These are generic methods for specifying demand. So it could be an urban consumptive need, or an industrial use need, or even crop irrigation. But the requirement here is that you actually know the megalitres per day that are actually needed for each day that you that the demand node is active. In contrast, the 3 models at the bottom of the screen, the IQQM crop model, the PRIDE model, and the Irrigator model, all model crop irrigation requirements given certain sets of inputs. So I'm going to talk today a bit more about the Irrigator crop irrigation model. So Irrigator is developed from concepts in the Food and Agriculture publication 56, which is crop evapotranspiration, guidelines for computing crop water requirements. And we've implemented the algorithm here that they use in this publication in source in our Irrigator demand model. So Irrigator basically provides, asks of the source model, or orders water for irrigation in the source model, water requirements for an irrigation district. So we're not talking about an individual farm or an individual field, but the requirements of a whole irrigation district. Irrigator estimates irrigation requirement using inputs of rainfall, evaporation, soil water balance, and crop characteristics. So when you want to use an Irrigator demand model, you need to set up a number of things. You need to input details about the crops that you want to grow, the irrigation district and some of its parameters, climate parameters, soil parameters, and some details about how you're going to decide whether or not to plant your crops. I can't cover all of that in the presentation today, but I'm just going to cover a few of the details to give you a feeling for how this demand model works. First of all, let's look at evapotranspiration. Here we estimate crop evapotranspiration, that's ETC, using a crop factor and a reference of evapotranspiration. So the crop factor typically ranges between 0 and 1.5, and it's typically an indicator of the development of the canopy of the crop. So the algorithm used by FAO in their publication uses 4 stages of growth for an annual crop. We have an initial stage, a crop development stage, a mid-season, and a late season. And I'll give you an example of that in source in a minute. But just before we move to the example, I want to talk about soil conditions. Now, I'm not going to go into a lot of detail here, but I just wanted to cover this one important sort of underlying principle, if you like, that is used in Irrigator, and that is how they define the available water content within a soil profile. So for the root zone of a particular crop, your crop has access to water in a particular depth of soil, and that depends on the soil water content at field capacity and the soil water content at permanent wilting point for your particular crop. So the difference between field capacity and wilting point gives a total available water for the crop to use and grow, and it's the demand model considers how that available water content is used up and how it can be replenished through irrigation, and it tracks that water balance, if you like. Okay, so I'm just going to switch back into source to go through a little bit of a live example of how that works. If you look at the node palette, so I'll just adjust my screens very slightly here. Here's the node palette. We have a water user down here. You can drag one of those into your model and link it up. Once you've defined what your demand model is, your node is going to look a little bit more like this one over here, the water user here. So before I open the water user, I want to explain a little bit about setting up crop parameters, because source does this under the edit menu. And if we move to crop parameters here, it allows you to set up your crops independently of any particular water user node. Therefore, you only need to set your crops up once, and you can use them in multiple water user nodes and multiple demand models if you want to. So we can add another crop, we can import our crops from an external file, or export the ones that we've entered here. I'll just add a crop, and we'll rename that crop. We'll call it wheat. And you can see that the crop factors, or it's actually shown as a coefficient here, are the 5 numbers in the top row of the table. These numbers represent the endpoints of each line segment shown in the little panel below, and you can see how your crop develops over a number of days. There's 30 days at the beginning, just the initial crop establishment period, then a growth phase where the crop factor goes up to 1, and then that's sort of reached maturity, and we have a canopy, full canopy for I think 60 days, and then we decline SNES at the end of that period. Now, if we thought that we liked intensive agriculture and we wanted to grow 2 crops in our year, we can click on this little button here, and it just repeats the pattern for another 180 days. Okay, so now we've entered our crop. I'll just accept that, and we can go into our water user. Now in water user here, first of all, when we first come in, I've been here before, so I've created an irrigator, but first of all we go into demand model, and we click on our right mouse button, and we get an option to select one of those demand models that we've talked about earlier. So obviously I quite like, I'm talking today about Irrigator, so we'll click on Irrigator again. In this particular case, it's created a new version of Irrigator, and it's stuck it in a folder called inactive models. Now, if I want this version to be active, I again click my right mouse button and click the set active button, and it will switch the two irrigator models. But today I'm going to look at again at this irrigator 0. We have to enter up here, well, a maximum irrigated area for our district. So I'll just put in, say, 3,000 hectares, soil moisture capacity. I'll put 20% in, and there's various other things you can add there. The other things that we need to put into our irrigator model are evapotranspiration and rainfall, and you'll see the same options are given that we've discussed earlier at the top here. And you can download, typically you'd want to link this model to a CSV file with a time series, daily time series of evapotranspiration and rainfall, so that you could run the model using those data. Then we have our irrigator. We can rename that if we want to rename it, but we want to add another crop. So we'll put another crop type, and you should remember when we're doing this that what we really want to do is build up a number of crops that are grown in the district. We don't want just one crop, because typically in an irrigation district you won't have solely one crop. You'll have a range of crops. So here I want to select, I'm not going to select rhubarb, I think I'll select wheat, because that's the one we entered, and you can see here we've got the two, it's doing a double crop through the annual period. Then there are a lot of other things we can add in this screen. The crop type itself has another set of options. So we put I need to make a planting decision, a few choices of parameters under planting decision, and target soil depletion, etc. But I'm not going to talk through all of those. These are things that will be covered in the November training for those who want to attend. Okay, so that's a very quick introduction to the water user node and the irrigator demand model. I'll just go back to the presentation now. I'll move on to talking about the environmental demand node. This generates demands to meet in-stream environmental requirements. So it does this by using a series of flow rules which are designed to capture the most commonly used sort of requirements. You can choose to have your environmental flow as an addition to, in addition to water orders from downstream. So for instance, you might have an irrigation area downstream of the particular point at which you want environmental requirements to be met. And obviously that irrigator will be ordering water from upstream reservoirs, and that water will pass through your environmental demand node. So you may only need to increment the water that's already passing through the node to achieve the aims of the requirements. And that's an option within the environmental demand node. You can also link your environmental demand node orders to accounts. So the accounts, you can keep an account for an environmental order holder, for instance. All right, I won't talk too much more about the environmental demand node, but I'll just run through these 4 flow rules in the middle of the slide here. A typical one is a flood or a fresher rule, which you specify a flow rate which you want exceeded in a particular, when meeting a particular requirement. So that might provide a high flow to generate some breeding cycle in fish in the river, or some other thing relating to environmental requirements in the river. And you might want to do that at a certain level or different levels for at different frequencies at that point in the river. You could also perhaps do that using a flow pattern. So you might have a high flow hydrograph that you want reproduced, and that would perhaps step the flow rates up over a number of days and then let them recede over a couple of weeks perhaps. You might put in a minimum rule which would maintain a minimum flow through the node over the period that you specify. And the last one here is a translucency rule, which is typically used downstream of a reservoir perhaps. So you might have an inflow to the reservoir. Perhaps you'll have a high flow event that flows into the reservoir, and you want at least a fraction of that high flow event to be released downstream. So you make a requirement that says, I'll take 10% of all inflows and request that as a release from our reservoir downstream through the environmental demand node. And then you get a similar sort of hydrograph, albeit at a much lower volume, that actually passes through your environmental demand node. All right, moving on to the final example for today is about water restrictions. And I'm just going to use a hypothetical example to explain how these work. If we imagine we have a small town, we call it River Town, and River Town relies on a single reservoir for its urban water supply, and most of the time the water supply conditions are good, so the restriction levels are at zero, when we call it stage 0 restrictions if you like. They can have their full water requirements. When the town's reservoir volume falls to 50%, stage 1 restrictions are implemented. And stage 1 restrictions might be the sort of things that we're aware of in Australia, you know, the sort of you mustn't water your lawn type restrictions. And in Rivertown, this once implemented, these stage 1 restrictions will not be lifted again until the reservoir volume rises to 65% full. The reason for having a separation between the implementation of a restriction and then the lifting of the restriction is that we don't want to be turning the restrictions on and off frequently. We want them only to come on when they're really needed, and then we only want them to be lifted when we don't think we'll need them again in the near future. So how do we do this in source? Well, it's an edit menu thing, a bit like we did for the crop parameters. So we go through into the edit menu, we click on restrictions, and we get a screen looking like this. We may have to add a set of restrictions in up on the top left there, using the right mouse button, and then you get a screen like this. So just as an example here, if we look at the top panel with the graph in it, the dotted blue line, which represents an entry into stage 1 restrictions when we have a falling reservoir volumes, and the solid red line, which represents the entry into stage 0 conditions when you have rising levels in the reservoir. So the y-axis shows a full reservoir as at 1 and an empty reservoir at 0. And if you imagine your reservoir volume falling from 1, say, it's in stage 0 restrictions, it falls down until it goes below the dotted blue line, and stage 1 restrictions are then implemented. Then it bounces around for a while, and perhaps we get a bit of rain and runoff, reservoir refills slightly, and if the reservoir level crosses the solid red line, it crosses back into stage 0. And that would be the same for any other subsequent stages you might have below stage 1. But that just gives a very simple example of how you set this up. So under the stage 1 restrictions, the value that's returned from the restrictions editor is 70%. So that means to say that when your water's a bit scarce, you'll only be supplied with 70% of your usual order, so don't water your lawns, basically. And in the eWater training module, we apply this restriction value to a demand time series. In other words, in the water user node itself. And how does this finally look? I've got a little figure here showing some results. The blue line shows the percentage full in our reservoir, and that tracks over this, I think it's, what have I got? It's just more than 10 years shown here. We can see if we look right from the start of the period, the reservoir levels are high and they fall down to 50%, and then the red line jumps from a 0 condition to a 1 condition. So that's the implementation of stage 1 restrictions. And then along comes a big rainfall and runoff event, the reservoir's filled and the restrictions are set back at 0 again. If you look a bit further on, we'd look at the last, well, the second to last implementation in 2000, between 2006 and 2008, if you can read that on your screen. You can see that restrictions were put in place, and then there was a small rain event. The reservoir filled slightly, but not enough to get rid of restrictions, and that was a good thing because the reservoir levels fell again and went quite low to 40% before we had a decent runoff event to remove the restrictions. So that's all I wanted to cover today. We've briefly described the minimum flow requirement node, the water user node, and the environmental demand node. Detailed descriptions of these nodes and how they work are provided in the source users guide and the reference guide. Both of these are available online, and you can actually link to them through your interface. So I'm happy to take any questions on what I've talked about today. Just bear in mind that if you're able to attend the training in Sydney, it's on the 16th and 17th of November. So I don't think we have any questions yet, but please feel free to send one if you want to. You could also send an email to forum_support, or sorry, send it to send any email questions to support@ewater.org.au. Okay, so I think my presentation must have been excellent because there are no further questions. I look forward to speaking to you again sometime in the future, and we'll be in touch regarding future webinars.